Hi, thank you for the organizer of ICOA International Conference on Optimization and Application 2021 for inviting me to give a keynote speech on innovation in artificial intelligence in the era of Industrial Revolution 4.0. Okay, my name is Muhammad Helmy bin Abdul Wahab. I'm the Principal Researcher of Advanced Telecommunication Research Center, Department of Electronic Engineering, Faculty of Electrical and Electronic Engineering, University Tun Hussein on Malaysia. Okay, so this is me, and I also act as a visiting research fellow at the Center of Excellence on Advanced Computing, University Malaysia, Perlis. Alright, so this is a little bit about me. So my area of interest, I'm working on the area of artificial intelligence, Internet of Things, data mining, and database area. So anything that nowadays, as we talk about the more on the IR 4.0, so I'm working more towards on the artificial intelligence and the Internet of Things. Okay, so you can reach my profile as shown in the slide, and then you can get more information about that. All right, so this is a little bit about the location of my university in Malaysia. So this is a little bit about the university. So the University of University Tun Hussein on Malaysia, UTHM, is located at the southern area of Malaysia. Okay, it's about near to Singapore, 1.5 hours to Singapore, and it's about 3 hours from Kuala Lumpur. Okay, so if you arrive from Kuala Lumpur, you need to travel about 3 hours to reach the university. If you're landing at the Changi International Airport, Singapore, it takes about 1.5 hours to reach the university. So our university more closest to Singapore, okay, rather than Kuala Lumpur. All right. Okay, so this is our new library building, which is in line with the main gate of the main entrance of the university. The shape of this library is a circle. So you can see that this is our new library. And the top of this library is our Vice Chancellor office. Okay, at the top of this library. And you are welcome to come here, and then we can have several collaboration. Right? All right, so let's talk about the Industrial Revolution 4.0. Okay, as in line at the current times, okay, most of these Industrial Revolution 4.0 consists of these 11 components. Okay, what we can see from the it shows that one of the areas that we need to explore is about artificial intelligence. Okay, in addition, we can have some Internet of Things, we can have cloud computing, we have the additive manufacturing, which is more concerned on the 3D printing, okay, big data analytics, how to deal with the big data, cyber securities, simulation, and advanced materials, okay. And all these kind of components may work together, may join together, may be combined together from each component. Okay, so the component not only can execute alone, but it can be integrated with other components. For example, I'm working more towards on AI, and it can be included the IoT as well, because IoT, as we all know, that most of the IoT system is the front line of data acquisition. Okay, nowadays people getting a data through the sensors, and the sensor will send the data throughout the internet to the cloud servers, and then will be processed by the big data analytics engine. And inside that, we can have several AI algorithm to be included inside. right? So this kind of enabling technologies will make the digitalization of the product-based industries driven by these technological drivers, right? So this is the way that we work now, which is based on these 11 components as in line by the government about the Industrial Revolution 4.0. Okay, so when we talk about these, one of the components that most closely related to this conference is AI. Okay, because when we talk about the optimization, optimization is AI. It's a part of the AI. Okay, so AI. What does it mean about AI? So I think everyone, this is not a new term. Okay, AI is not currently a new term. AI is already coined out in 1956 at the Dartmouth Conference by John McCarthy. Okay, talking about the AI, which is try to mimic the way people think. Okay, they try to mimic the way the people thinks. So this is the general definition of AI. So anything, okay, what the human have, so AI try to mimic, to emulate, okay, to copy what the human have. For example, the thinking process, okay, the intelligent process, try to transform in the mathematical model that can be done in the system, in the computer system, so that the system will act or react like a human. All right. So this is the way we talk about AI. All right. So this is the John McCarthy who coined out the terms of artificial intelligence in 1956, okay, at the Dartmouth Conference, which is the main objective of this AI is try to make an intelligent machine, okay, intelligent machine, especially the intelligent computer programs, okay, that have the ability to make a decision like a human, which is related to the similar task of using computers to understand human intelligence. Okay, but AI does not have to confine itself to methods that are biologically observable. All right. So this is the father or the founder of artificial intelligence, which is John McCarthy from Stanford universities. Okay, so this is a very general definition of AI. So we have so many definition, and there is no standard definition, which is most of the AI defined by the scientists, which is based on the perspective. Okay, to what extent the AI has been extended in the definition as defined by the each scientist. Okay, so for example, we have another definition by uh, Deakin, okay, John Deakin, which is talking about the knowledge representation. Okay, how the human solving a problem, how the human is showing the step by step to find the solution for each problem. Okay, so that one is defined by the John Deakin. Okay, so there are many definition has been given by the scientists, which is depends on which spectrum of view, okay, has been defined by them. So the definition of the AI will be concerned on that particular spectrum, right? Okay, so this is a little bit about the AI, the history of AI. So it has been introduced as early in 1950s, which is at that time we consider that AI as a search, all right? And then the birth of the first layer of neural network perceptron in the late 50s, and then we can call it start in the late 50s until the middle of 70s. We call it the golden age of AI. So at this point, so most of these AI application has been commercialized, all right? And then we can have the dark ages of AI since 1974 until the 1980s. Okay, at that time, most of the role-based system has been taken place, right? And then the expert system has boomed up in 1980s until 1987. And then we have again another dark age of AI. We call it the AI winter during the 97 until 1993. And then we we have another challenging, okay, from the 94 until 2010. Okay, it's about the searching to learning. And then now, AI has been taken place in the area of fourth industrial revolution from starting 2010 until now. And then most of the application has been developed are more advanced application, which utilizing one or two or more algorithms that AI can solve. Okay, so this is a little bit about the history of AI. How do we look at the AI as a search at the early stages, and now we can have AI in the advanced application. Okay, as we all know that AI nowadays have three, okay, categories. Okay, artificial narrow. Now we consider the classical AI is a artificial narrow intelligence. Okay, and then we have the another artificial general intelligence. Okay, artificial general intelligence, which is more closely towards the human. Okay, that's mean if we are building the robot in this AGI, okay, artificial general intelligence, okay, we are close with the robots. It is very difficult to differentiate between what is the human, what is the robot. And then we have another categories of AI, which is ASI, artificial super intelligence, which is the robot that we develop is far superior than the human. Okay, so this is the trends now. All right, so that we talk about the strong AI, we talk about the weak AI. Okay, the strong AI is trying to replace the human. Okay, we try to build the system that can replace the human. That one is not very good application, because the main objective of this AI is not try to replace the human, but it can assist, okay, or speed up or accelerate the job has been assigned by the human, which is more safer, it's done by the AI, okay, instead of replacing the human. And the weak AI is the system that build, okay, which is include AI inside the engine, which can help, okay, the user or the human to accelerate the process of solving a problem and making a decision. All right. Okay. And when we talk about the IR 4.0, there is another area that we cannot escape, which is Internet of Things. Because why Internet of Things is very important nowadays? Because Internet of Things is the first line data acquisition. Since most of the AI system are now depends on the data, depends on the input provided by the user, okay, now the input now has been controlled by the sensors, and the sensors will be used to send the information, okay, collected by the sensors, sending to the cloud, okay, through internet, and then the cloud will receive and process all this data, which is we employs all the AI algorithm inside the clouds. All right. So Internet of Things, which is the new terminology, it's not currently a new, but the term was coined by Kevin Aston in 1999 during his work at Procter or Gamble. And the idea of the IoT or Internet of Things is about connected devices. Okay, connected devices had been around longer, at least since 1970s. Okay, so back then the idea was often called embedded internet at that time. Okay, we call it embedded internet or pervasive computing. But nowadays we have the Internet of Things or IoT. All right, and as we all know, sensors and actuators embedded in the physical object are linked through wired and wireless network. Okay, often using the same internet protocol that connects the internet. All right, so Internet of Things comprises things that have unique identities and are connected to the internet. So the main focus of the IoT is the configuration, control, and networking via the Internet of Devices or things that are traditionally not associated with the internet. Okay, for example, if you have the We want to develop the palm that can send the message, monitor the reading of the palm. You can have the utility meter. Okay, you can have the reading, the utility meter to your mobile phone. Okay, you have the car engine. Now you can start your engine through the mobile phone. So everything now connected. Okay, is closing the gap between the cyber physical system. All right. Okay, and IoT is a new revolution in the capabilities of the endpoints that are connected to the internet. All right, so this is the picture of this how IoT, big data, AI that contribute to the innovation nowadays. All right, so what we can see that we have data now. We have a lot of data nowadays, which is generated by the sensors, by the system, okay, by the social media, all right? And then we have the users, which is use the devices, the mobile devices, and we have the connected devices using the internet. So what we can see that by using the big data withdrawn from this connected device, we can create a digital twin of the physical world. AI analytics on digital twin is expected to drive the optimization and automation of the existing business process and inventing new business models, solution, and products. Okay, so this is why we're talking about the innovation, how the innovation in AI has been taken place in the new trends, so that most of the AI system can be in many fields, can be in any fields. All right. So any application that we develop nowadays, we can put AI inside. All right. So this is some of the example of areas, okay, that we can employ most of the AI and IoT. Right. For example, we have the smart factory. We're talking about smart. So when we're talking about the smart, we can have the smart cities, we can have the smart factories, we can have smart home, we can have the smart house, we can have the smart waste management, everything. All right. And then we have the connected marketing. Okay, how do we use the platform to make marketing boost up to reach the users? All right. And then innovation, reduce time to market. Okay, connected gaming, micro payment, smart grid, connected supply chain, new work style, okay, physical cyber security, and business process outsourcing. So nowadays, when we talk about the IR 4.0, so these are all the most of the keyword, okay, most of the area that we need to focus on. All right. Okay, so this is the very simple smart application model, okay, that employs the artificial intelligence plus big data plus IoT. So we can see that these are areas that interrelated each other. All right. So as I mentioned before, the IoT is the first line of data acquisition. Okay, it must be placed at the top, and then we have the people process, and then we interface all these kind of process with the application. Okay, so that user interact with the system through the user interface at the mobile phones or the computer, and then inside the mobile phones we have the system which is done the data analysis, which is done the data ingestion, edge computing, and edge, and which is utilizing most of the AI algorithms and big data algorithm inside that system. So this is, we call it the smart application model, which is most of the innovation in AI. Okay, so what we can see nowadays, if you have the system now, so your system is located at the cloud server, and then you can access this system through your mobile phones. So in between, so the application and the users are interfacing with the application user interfaces. So all the processes will be done at the cloud servers, which is most of the processing done by the AI and big data analytics. All right. So this is the very smart application model. It's a very simple model that we can utilize. All right. And then again, Okay, when we talk about the layers, all right, we talk about layers. We have the 7 layers of Internet of Things, okay, which is in the layers itself, we can apply for the AI algorithm inside. Okay, for example, we classify these layers into 4 categories. Okay, fog, cloud, big data, and business value. So at the fog level, we have the things, okay, which is the devices, and we have the connectivity. Okay, maybe we can use the Bluetooth for the short range. Maybe we can have LoRaWAN for long range. Okay, and layer 1 and layer 2 most probably related to device, sensors, controllers, and communication protocol. And then we come to the second categories. We have the global infrastructure, okay, which is most of the cloud. Okay, this is provide the storage. Okay, provide this storage. Most of the storage technology that we use nowadays are in the cloud model. All right, and then we have the big data. Okay, big data, we have the data analysis and data ingestion because we receive huge amount of data per day. So that these kind of data analysis engine and data ingestion engine we use to make a report to mine using the machine learning techniques. Okay, and the big data itself, we can harvest and storage of things data. So any generated data, okay, now we can store in the cloud database, and then we can have the big data engine to analyze. And then the top class of these Internet of Things layers, we have the business value, okay, which is we have the application, which is custom application built-in things data, which is as a user interface that interfacing between the people and uh, uh, the big data, cloud, and fog. Okay, so the people is a transformational decision making based on things data, so that the people can use the data provided or display at the application to make a decision. All right, so which is this is the layer, the 7 layers of Internet of Things. Okay, so this is example of the application that we developed in my team. Okay, it's a smart recycle bin, which is a reward and redemption system for recycling activities, which is we want to encourage the awareness of recycling in Malaysia. Okay, so that this project is collaborate with the solid waste cleansing authorities in Malaysia with UTHM, so that we use to develop the solution in order to encourage the awareness of recycling activities in Malaysia. So what is the most motivation of this work? That as we know that most of the recycling rate in Malaysia is very low, okay, and then we want to encourage all the Malaysian to recycle. And then as we know that the Ministry of Housing and Local Government aims to achieve the recycling rate of 22%. So that we propose the solution to implement the 3R concept and practice in solid waste management system. All right. So 3R means reduce, reuse, and recycles. Okay. So people who recycle the waste, we can give the points to them, and the points they can use to buy or purchase anything online or whatever. Okay. So this is the way we want to encourage the users. All right. So this is the conceptual diagram. Okay. So what we can see that we can divide this model into 3 parts. Okay. The first, we have the bin processing unit. The second part, we have the local data processing center. And the third one is a web portal. Okay. So most of this our work are located at the bin processing unit. Okay, because we put the material classification engine to segregate the waste. So this is the way the AI inside the engine. Okay, so how do we differentiate between the empty bottles and bottle filled with water? How do we differentiate the peppers and rocks? Okay, because sometimes the people trying to cheat to get the point. Okay, so that by this kind of material classification, we can distinguish this item is fake, this item is real waste. All right. So this is the way we work in the material classification engine. And then after we produce the bin processing unit, all the data, okay, based on the bin will be sent to the local data processing center, and then will be uploaded to the cloud storage, and all the points, all the data will be processed and then will be displayed at the web portal. Okay, so then we can use this kind of web portal to check the point that the user get, and he or she can decide whether they want to uh, redeem it or just collect another points. All right. Okay, so these are some of the papers, the conceptual paper that I presented in the Beijing, okay, in 2014. And then we have another exhibition for the this solution in the Vietnam in 2014. And this solution won the Special G-Trax, okay, Green Technology Exhibition Award at Ho Chi Minh. All right. And then these are some of these papers that we presented for this research project. Okay, and then this is another system. Okay, we developed the MySign. This is a wireless wearable sign language translator device, which is to help the normal people to communicate with the mute people. Okay, so that most of these normal people are unable to communicate through the sign language, because some sign language require special skills. So that, but we can see that we know that the mute people can have the ability to communicate with the sign language, so that we provide the smart gloves. Okay, the smart gloves consist of like sensors, okay, accelerometers, and Bluetooth connection to connect with the apps that we develop in order to help, okay, the computer, the apps to translate, okay, the sign language, okay, move by the mute people, so that we try to translate the movement and translate what are the words trying to say by the mute people. Okay, so that, for example, hello, how do we represent hello in sign language? So the mute people will try to move the hands and fingers, and then the movement will be detected by the flag sensors and then processed by the Arduino, and then we can see that the output of the words pronounced by the mute people displayed in the mobile phone. Okay, so this is the best way to communicate with the mute peoples. And in addition, okay, we are now working that from these mobile phones, okay, we type the words and then how the apps can move the fingers so that the mute people can understand what we are trying to reply to them. Okay, so that's why we use the deep learning in order to translate, okay, the words typed by the user at the mobile apps, and then process and converting to the movement of fingers in sign language, okay, and vice versa. So what we can see that we already have several prototypes, okay, with the improvement, and then we can have some a good a good apps, okay, that can help people to communicate with the mute people. All right. So these are some of the achievement of the project here, and then we can have the one grant, which is internal grant, and then we publish several publications on these projects. All right. Okay, so this is another solution, which is we work with the 4 universities to develop the intelligent mosquito trap system, which we try to combat the dengue with the mosquito itself. Okay, so the main purpose of this mosquito trap is try to attract, okay, the mosquito to come to this trap and then lay eggs. Okay, so then when they lay eggs, they put their legs inside the chemical inside, and then all the eggs will be died, and then the mosquito moves to another place, okay, and try to lay eggs to the other place, so that when they try to put their legs into the chemical so that it will kill the eggs inside that water as well. So we try to develop this mosquito trap with the equipment of the IoT system. Okay, we try to put the humidity and temperature and water level sensor, and then connected with the Arduino, and then we can have the buzzer and the cloud server. So we use simple knowledge representation techniques inside this kind of application, so that it can help the sensors to detect whether the water level is reached the need to be added a new water, or the temperature is too hot, or the humidity is not too humid, so that we need to add up another chemical inside. So this is the way we work for the intelligent mosquito trap system. All right, so this is currently the first prototype has been released for this project. All right, and then we have another project. It's a real-time driver drowsiness detection with monitoring system, which is we try to develop a driver drowsiness detection for heavy vehicle drivers, okay, especially the trucks and then the express buses, okay, because most of these drivers are always drowsy during the driving time, okay. So that we just developed a small solution. The device is small and easy to install at the dashboard or windscreen, okay, so that it provides the monitoring system that notifies, stores, and display the image of detection in the cloud. All right, so that uh, the system have the market potential for heavy truck manufacturers and commercial buses for logistic operators. So the objective is we want to ensure the safety of the other road users, okay, improve road safety awareness among drivers, and safeguard the business interests of transport operators. Okay, all right. So this is the way how the system works. Okay, we place some cameras, and then we have the driver face detection algorithms, and then they will detect the eye area attraction, and then compute the aspect ratio, so that when the eye is trying to close, so the buzzer alert to the driver, so they capture image and store in the local storage, and then we upload the image to the cloud server, so that the company, okay, the supervisor or the managers can monitor this kind of uh, image taken by the cameras. All right. So at this point, we use the Pi cameras. We have the Raspberry Pi, and then we have the buzzer. So we try to develop this kind of industrial application because this is a really the community really needs in the community. Okay, so that we try to develop this application. All right, there is another community project, okay, which employs the AI. So we collaborate with the school, try to develop the compliance gap, which is due to the COVID-19. So we come up with one of these solution, okay, especially for Muslim, okay. So we can help the Muslim man in various way. It provide prayer mat in a cap in folded shape that can be opened to full-size prayer mat and head over, so that we include the smart LED devices that can show the Qibla area, Qibla direction, and count the rakaat. So iCap operated in three ways: as a normal cap, okay, as a copia or head cover, okay, while praying, and smart LED device and prayer mat easy to perform salat in these new norms. Okay, so these iCap are suitable for Muslim men to wear it. So the iCap best apply in Islamic industry halal hub and in the educational purposes. So this project is working together with the Sekolah Menengah Pancing, okay, Pahang, with the aid of the most of the teacher Faisal, and then teacher Wahiri, okay, and the students to develop this kind of compliance cap. So we call it ICAP. So this is a very useful application due to COVID-19. All right. So as a conclusion, there are so many innovation in AI, which is developed in the most of the industrial application that we can apply most of the AI techniques such as the optimization algorithm inside in order to make a decision. And then perhaps AI can also be extended and more advanced on the helping the user to make more intelligent system, and so that the system can assist the users in making a good decision. All right, so thank you very much for your attention. So you can contact me with the emails and connect with me at the LinkedIn website as stated in the slide. So thank you very much.